Okay, today's lesson is going to have to do with local minimum and maximums. Okay, this is actually something that you guys should have learned in IM3 Advanced. Okay, folks, please, if you have trouble hearing me, please unmute yourselves and let me know. Okay, so let's say we have a graph here. Okay, this dot, don't ignore that it's a different size. That's no big deal. Okay, um, it's a little bit bigger. It's no big deal. All right. Now, let's pretend we have this graph here. I want to turn your attention here. Let's pretend we have this graph. Okay. Now, these two on the top, these two blue dots on the top, we're going to call that the local maximum. It's very intuitive, nothing crazy. Okay, that's probably what you would expect. This is called your local minimum. Again, very intuitive, probably what you would expect. Okay, and this dot is a little bit off. Okay, whoops. So this dot should be a little bit lower, like that. Okay, because it's 1 comma negative 2. Okay, now let's talk about this increasing, decreasing stuff. Again, this is stuff you should have learned from IM3 Advanced last year. Okay, so I typed in my first and last name, Clifford Chen, and this is the guy that popped up. Okay, so we're gonna use this guy right here. All right, and he's skiing. These are ski equipment. Okay, now if he's skiing from left to right, he's going uphill and then downhill, and then uphill, and then downhill. Okay, so this is increasing, decreasing, increasing, decreasing. Okay, so the orange was increasing. That's why we got increasing here. The green was decreasing. That's why we got decreasing here. The pink was increasing. That's why we got increasing here. And the blue was decreasing. That's why we got decreasing there. Okay, so when you think of increasing, decreasing, I want you to think of uphill, downhill. Okay? Now, let's say with your fingers, okay, so the increasing, decreasing part is easy. And now let's talk about this part. This part is not hard, but people get confused on it sometimes. Okay, I think I found a way to explain easy. Now, if we were in class face to face, it would be even easier for me to explain. I think I can explain pretty easy digitally. Okay, through distance learning. Now, let's say with your fingers, let's say this was a string. Okay, let's say this were a string, and you were to pinch these green dots, these ends basically, with your fingers, and you were to spread the string out, pretty much straighten it, almost straighten it. Okay, wouldn't you agree that this points left? This orange segment points left? Wouldn't you also agree that this blue segment points to the right? Okay. All right. Let me. So this orange segment points left. So then this points left. Okay. That points left. All right. Now this blue segment, after pinching it, points right. So this symbol points right. Okay. Now this green segment hits 2 endpoints. Okay. And again, we're only paying attention to the x values of the endpoints. Okay, let me choose a different color over here. Let me choose gray. Okay, we're only paying attention to the x coordinates. And what 2 endpoints does the green highlight hit? It hits -2, +1. And that's how we get those. Okay. All right. Now, same with the pink. The pink hits 2 endpoints. Okay. The pink hits, let me delete this green dot, delete that green dot. The pink hits 2 endpoints of +1, +5. And that's why you got +1, +5. Okay. All right. And in the green and pink scenario, because these this hits two endpoints, the arrows always point left. Let me recap on that. If it hits two endpoints, it always points left, the arrows. Okay. All right. So I just recapped on the green and pink, and let's again recap on the orange and blue. If you were to pinch these arrowheads and spread it out left and right, okay, or just spread it out and straighten the string, almost straighten the string, remember this orange points left, so that's why the symbol points left. This blue points right, that's why this symbol points right. Okay. Now, for the most part, this, and I'm sure you guys know this means, the way you read this is x is less than or equal to -2, x is greater than or equal to 5, and x is in between -2 and 1 inclusive. Inclusive means that it includes -2 and 1, and same thing goes for this. Okay, x is in between 1 and 5 inclusive. Okay, all right. So let me show you that we pretty much covered the most common scenario. Let's pretend your scenario looks like this. Okay, let's pretend your scenario looks like that. Whoops. Let's say that were a hollow dot. Okay, if that were a hollow dot. So now, if this were a hollow dot, okay, that means it's not inclusive. It's not inclusive of this 5. It's excluding 5. Okay? When there's a hole, when it's a hollow dot, that means there's a hole in the graph. Okay? The graph includes everything except for that dot. Okay? So the way that's going to change things is one simple thing. Instead of or equal to, this is just going to be, we're going to take away that underline. Okay? We're going to take away this underline. Okay, so I made changes. I made changes now. Okay. I made changes now here and here in those symbols. Okay, I took away or equal to. All right. So now that's a scenario you're going to come across sometimes. Now let's pretend your scenario looked like this. Okay. I'm going to move this up. I'm going to move that up there. And I'm going to move this here. Whoops. Okay. Now let's pretend you have something that looks like this. Okay. This is a little bit, you're not going to encounter this scenario too many times, but it's worth talking about. So now in this case, for the pink segment, it includes the 5. Remember, we're only focused on the x coordinates. Okay, we're only focused on the x coordinates. Okay. And what I was going to say, it includes the 5 in the pink's case. So we're going to bring back this or equal to sign. Okay. And in this case, for the in the blue's case, however, this blue excludes the 5. It excludes this point, I should say. And the x coordinate of this point, remember, because we're only concerned about the x coordinate, is 5. So excludes is 5. That's why this remains just greater than. It does not become or equal to. Okay? All right. And of course, this y coordinate, which is irrelevant to this yellow box. We're only working on the yellow box. Okay. This y coordinate would change this y coordinate would change for this point right here. Okay, it would be like 12 or something like that. But I'm not worried about that right now. That's just an FYI. Okay, so that pretty much wraps up the first part of today's lesson. I want you guys to do something like this. Okay, some problems only ask you for the maximum minimums. Okay, so you only do the red boxes. Some problems ask you for the red boxes and the yellow box. Okay, and I want to give you a heads up later on. Okay, we're gonna write it in this fashion right here. Some of you guys may have done it before already, but we're gonna write it like this. Okay, this is um, this is a good way of writing it, but the more mathematically mature way of writing it, so to speak, is like this: -2, 1. Okay, like that. And let's pretend that did not have or equal to, then you would write it like this. Okay, 1. And because this 5 does not have a or equal to, you're going to write it with a parentheses. Okay, so this is a good way right here, but this is the more mathematically mature way of writing. But don't even worry about this now. Okay, we're going to do that later. We're going to handle that later. Okay, so if it asks you for the yellow box, just leave a little bit space, maybe right here. Okay, after the increase and decrease, because we're going to add this mathematically mature way of writing it. Okay, that wraps up today's lesson, folks. I'm going to teach you something else in a little bit, but it's like even easier than this. Okay, so go ahead and hang on for a second. Let me stop